This video is 1.1 linear functions. I skipped to page 9, so these notes will be page 9, 10, 11, and 12. So I skipped the domain and range for now, and I'll go back and do another video on that. But for right now, we're going to do linear functions. So let's talk about, first of all, slope. Well, slope is your average rate of change. So if you hear rate of change, I want you to think slope. And recall that the formula for slope is, and we use an M, is slope is rise over run, okay, or delta y, the change in your y's, over the change in your x's. And we use a delta symbol, which means change, okay? So it's your change in your y's over your change in your x's. Okay? So that's what the slope formula is. Now, when we actually did it, we would use it this way. So some of you may have seen it this one. Slope is delta y over delta x, and another way to write that would be y2 minus y1 over x2 minus x1. Okay, so 1. So that shows you that you have two xy points, and you can find the slope between the two. A little review is, if the slope of the line goes this way, it's a positive slope. If it goes this way, it's a negative slope. If it goes straight like this, think of it like skiing, it's a zero slope. Or, let me erase this little squiggle I did here. If you go straight up and down like this, if it lets me right here, this is no slope or undefined slope. Okay? And as we go through, you'll see why, but that's no slope. Now, the second fraction is preferred for the notation in calculus. All right? So this is what we use a lot. The slope of a line is often described as a ratio of rise over run, which I showed you. Another way to think of slope is as the amount that is the dependent variable changes for increase by 1 in the independent variable. So if you'll notice, the dependent variable is on the top, your independent variables on the denominator. So just say numerator and denominator. In other words, as x changes by 1, what happens to y? So let's practice some slope problems. So I have these 2 points. Now I'm going to give you a little hint. When I do this, I always do everything vertically. I don't like it horizontally. So I'm going to put the point 1,7 over the point underneath the point 3, negative 2. So we're going to find what the slope is. Slope is delta y, the change in your y's, over the change in your x's. So we start with the y's right here. I'm going to say, okay, that's negative 2 minus 7 over 3 minus 1. And so that's negative 9/2. Okay, and if you were to graph that, and I prefer them in their fractions too. So see how the fraction form is helpful in calculus. That means the slope slants to the left. Okay, negative 9/2. And the other thing I want to show you is the greater the number, the steeper the slope. So that's not too huge of a slope, but it would look in that direction. Let's try between 4,3 and negative 1,3. So if I put the negative 1,3 underneath, because that's how I like to do it, and I got slope is, I keep making marks here, I'm sorry. So slope is delta y over delta x, and when I do that, I have 3 minus 3 all over 4, and it turns to a plus 1 because I'm subtracting a negative. So if I get 0 over a number, that means this has a 0 slope. And if you were to graph that, 4,3 and negative 1,3, that's what the line would look like. It'd be a 0 slope. 2,6 and 2,0, so I put the 2,0 here underneath. Do my slope, delta, the change in your y, so I have 6 minus 0 over 2 minus 2, so I have 6 over 0. You cannot divide by 0, so that means this line looks just like this. It's undefined. 0 slope, just to remind you, 0 slope and undefined slope are different. So please don't think they're the same, all right? When we compute slopes in situation, we must make sure to include units in our answer. So this, I just had you practice the math part of it. So when we start doing word problems like this one right here, you're going to have to start putting units, all right? So let's start reading this. It says, what is the annual rate of change if we have 124 million internet users in the United States in 1990 and then 205.3 million internet users in the US in 2006, and the growth is linear? So, and they said annual rate of change. As soon as you see the word rate of change, I want you to think slope, okay? So there's rate of change. I want you to think slope. So I've got to do slope. So I know the slope formula is delta y over delta x. Now, here's the thing. You're like, well, I don't have any points. So we have to make points, and you have to know what's independent, what's dependent. So let's look at the first part. We have 124 million users in 1990. So you have to think, what depends on what? Well, the users depend on the year, because we're talking the year. So the first point could be, oh, in 1990, we had 124 million users. And then when you make this point, make sure that you write years for here. Okay? And then this right here, let me erase these little dots here. This right here, make sure you say millions of users. Okay? So this is in millions. Now, I'm going to show you something after I do this. Now, once we do that, and I look at it, now I've got to find another point. So I look at it, okay? There was 205.3 million users in 2006. So here we're going to write 2006, right here. And there was 205.3 million users. Now I can do the slope, but I want to show you a trick before you do this. A lot of times when we do word problems in calculus, we always find a starting point, because time keeps going. Time is a continuum. So a lot of times we use something where we're going to say t is 0, meaning at one time we're going to call this 0. So right here, 1990 is the first one we have. So I'm going to say here, time is 0 here. So we're just going to call this 0. So I can actually change this point here, for simplicity's sake, to the 0, 124. So the 0 stands for 1990. I'm not saying it doesn't, but we're going to call that 0. Then if that's the case, what would this point change to? So you'd have to actually take 2006, subtract 1990. When I do that, that's 16 years later. It's 205.3. It actually makes your math easier as long as you realize that that 0 stands for 1990. Okay? So now let's go through and do the slope. So I'm going to go bottom to top. So I'm still doing the y's first, but I don't want to have negative numbers, so I'm going to say this minus this over this minus this. And you can do that as long as you stay in that order. So I'm going to say 205.3 minus 124 all over, that's 124 guys, all over 16 minus 0. So my slope comes out to be 81.3 all over 16. And as a fraction, either that or decimal, I have 5.08 or roughly 5.1. Okay, now normally I like fractions, but I want to show you that's really 5.1 over 1, if you will. Now I need to know what the units are. So if you label the crap out of it, isn't the millions on the top and the years on the bottom? And this line, the line stands for per. So it's going to be millions of people per year, because you've labeled it and the millions, and this stands for the word per. So basically you're saying, oh, that grew about 5.1 million people per year. Okay? I always tell everybody, if it purrs and it's not a kitten, it's a rate. So there's a rate. Okay? So now you see how I did the units. Let's write some equations of some lines. First of all, there are two common forms. Okay? The one that you're used to and that we've used a lot in class is y equals mx plus b. Now in pre-calc, I like to actually write it as y equals b plus mx, okay? You say, what is the difference? You're right, there's really not much difference, but when I go to do this, you know the m stands for slope, because we've been practicing that, and the b stands for your y-intercept of your graph. When I do this for pre-calc, b is like your beginning or your y-intercept, and your slope is how it grows, whatever. So it helps, I think, sometimes to write it this way, but this way is fine too. The other form is called the point-slope form. So this is called the slope, right here. This is called the slope-intercept form. And I want to show you something. Math people, we're cool, but we're not always that ingenuitive. See how I have slope and intercept in there? It's a slope-intercept form. This one's I'm going to show you is called the point slope form. So that, guess what's in it? A point and a slope. So it's this way. Y minus y1 equals mx minus x1. Where x1, y1 is your point. Okay, that's a little 1 here. x1, y1 is a point. And m is still your slope. When writing an equation of a line, keep in mind you always need two pieces of information when you go to write the equation. You always need either the slope, so you need a slope for both of them. You either, if you're going to do the slope-intercept form, you need the y-intercept. Or if you're going to do the point slope form, you need a point. So you need two things. You always need the slope, but you need either the y-intercept or the point. Okay? Once you have these two pieces of information, you can substitute the x and y values from your point and the slope m value into your formula. We'll illustrate two methods of writing the equation of a line. Okay? So let's go to the next page. Example 1. Write the equation of a line passing through the point 3, -8, and the slope 2/3. Well, this one's an easy one. I have a slope and I have a point, so I'm going to use point slope form. So I'm going to write the formula y minus y1 equals m parentheses x minus x1. All right. So here is my x1, y1. All right. So you just throw them in there and you throw the slope in there. It's really kind of cool. So make sure you put it in the right spot. If I put a -8 in there, it turns +8 because it's already a minus, equals the slope, which is 2/3. Then I have an x minus 3. You just did the equation of a line. How hard is that? The only thing I'm going to suggest is that you move this over, because on your calculator, if you were going to graph this, the y needs to be isolated. So I usually move this +8 over here to a -8. So you can leave it this way, 2/3 x minus 3, and then have the -8, which is fine. I would accept that. Or if you multiplied this all the way through, like did the distributive property, so this is good, I would accept this. And this, if you multiply it through, you'd have 2/3 x minus 2 minus 8. So then you'd get 2/3 x minus 10. When you do that, you've just made the y-intercept is -10 and the slope. So this right here and this are the same equation. This is just written in a different form. This is point slope and this is slope intercept. But it's the same line. If you were to graph it, you get the same darn line. Okay? Here it says write the equation of the line passing the point 2, 5, and 6, 8. So if you want to stop the video and try it, that would be good, and then go through it when I do. I just don't stop. I just keep going. So here's 2, 5, and I have 6, 8. So I have 2 points, but I don't know the slope. I know I need to know the slope, and I need to know the intercept. So how about we do point slope form just for practice? So I got y minus y1 equals m x minus x1. So I can pick either one of those to be my point. That doesn't matter. But I have to find the slope. So let's do the slope here. Slope is delta y over delta x, and let's change my y. So I've got 8 minus 5. I'm going to go this way over 6 minus 2. As long as you do the same direction, we're all good. So it's 3/4. Okay? So now I can put 3/4 in that spot right here. So I have y, and I'm going to throw in one of the points. So I'm just going to use the top one. So I have y minus 5, because this is an xy, equals 3/4 x minus 2. So there's my equation. Move the -5 over, so I have 3/4 x minus 2 plus 5. I would accept that. That is a nice equation. Or if you want to multiply it through, I'll show you how it'd look the other ways. So it'd be y equals 3/4 x minus 3/2 plus 5, and that would actually go to y equals 3/4 x plus 7/2. So now that's a 3. Let me erase that. This is a 3. So basically this equation is the exact same thing as the other one, but this is in slope intercept form. Okay? Now let's write the equation line here. Now again, this is kind of the same information we had above, except they did a nice thing here. Do you see this? I have the point 013. So if it's 013, what is that? Oh, that's my y-intercept. If they give you the y-intercept, guys, use that formula because you already have it. All you gotta do is gotta come up with the slope, which you'd have to do anyway. So I'm gonna do this. Now if this is xy, you know the point 013, and let's pick the next one, 210. Okay, so if I were to do the slope, okay, I'd say, all right, let's move, we got some room here. So I do slope is 13 minus 10 all over 0 minus 2. So you have 3 over a negative 2 or negative 3 halves, okay? So, and then I have the y-intercept, so I can say, okay, y equals b plus mx. In the b spot, I put my intercept, which is just 13, and my slope is minus 3 halves x. So if they give you the y-intercept, guys, use that form because now you've come up with the equation of that line. All right? One more page. Now let's talk about parallel and perpendicular lines. Okay, parallel lines, of course, I'm just going to make a couple parallel lines. I just happen to have positive slope. Parallel lines never touch. Okay, so what's that have to do with slope? Well, two lines are parallel, and in math speak we use this symbol. It looks like 11, but that means parallel. Okay, if their slopes are the same. Okay, so my lines are parallel if their slopes are the same. Okay, so let's practice this. Now this is where we're getting into, okay, do we know what we're talking about? So I want to write an equation of a line that has this point, so I'm going to write little x and y, so that's on the line, but it's parallel to this line. So this is where it gets kind of confusing. So I'm going to show you what I do to kind of make sure that you know what's going on. So I want to write an equation line which is parallel to this one. All right. So I always kind of do this. I make like a big T, and I'm going to do the old line and the new line. All right. So the old line is y plus 2x equals 7, and we want to write a line that's parallel. So the new line, and it's through the point 1, negative 2. Okay. So we want it to be parallel to 1, negative 2. Okay, so before I do this, I have to know the slope, and I need to know I have a point. I already got the point, I just need to know the slope. How do I find the slope? Well, if you isolate your y over here, and if I move this over to the other side, I have negative 2x plus 7. What's ever in front of this x is my slope, right? So this is a negative slope. My new line has to be parallel to that, so now I know the slope of my new line has to be negative 2 because they have to be parallel to each other. Now I'm all set. I have slope and I have a point, so I can use the point slope form. Y minus y1 equals m x minus x1, and I can plug that in and come up with a line. Y, and it's going to be plus 2 because it's a negative 2 for the y. Slope is negative 2, x minus 1. So now I have y equals negative 2, x minus 1, and I'm going to move that over and make it minus 2. Okay? There's your new line. So if you set it up this way, your only thing you need from that old line is the clue of the slope. It doesn't matter anything else. And so I bring it over here, and then I have my new line. All right? Let's try another one. Let's try perpendicular. All right? Perpendicular lines kind of cross like this. So if I had a line like this, perpendicular would make a line like this, and they would form a right angle. Okay? So two lines are perpendicular, and that's a symbol we use for perpendicular, if their slopes are negative reciprocals. Okay, what does that mean? Well, negative reciprocal means you're going to flip it and change the sign. So, for an example, let me use an example. If I had a slope of 2/3, a perpendicular line would be negative 3 halves. Okay? So if I had a slope of 3, perpendicular would be negative 1/3, because there's really like a 1 there, and you'd flip it and make it negative. That's negative reciprocal. Okay, so let's try writing this line. So I've got to go through this point, so let's do the old new thing. It really comes in handy, excuse me. So here's my old line, which is y plus 2x equals 7, same line we had, and we want to have a new line, and the new line has to go through the point 1, negative 2, but it's got to be perpendicular. Okay? So again, I'm going to isolate it, which comes out to be the same. What is the slope here? The slope here is negative 2. Well, the slope of my new line has to be a negative reciprocal because they want it to be perpendicular. So negative 2 is really over 1, so I flip it, it'd be a positive 1/2. All right? Now I have a slope and a point, so I can say y minus y1 equals mx minus x1. And I'm going to throw in that point, so I have y plus 2 equals the slope, x minus 1, and I'll move that over. So I have y equals 1/2 x minus 1 minus 2. And there is my new line. And it's going to be perpendicular to that line. That ends this video.